Hello, good morning.
Good morning, sir.
All of you there? Only 11 I have seen. What about
Yes,
the
sir.
remaining? 10? What about the remaining?
On the way, sir.
Very good. Good morning, one and all. So today we are going to talk about the projection of planes. In the earlier classes, we have discussed already projection of lines and points. Okay. So today we'll go with the projection of planes. So a plane surface may be defined as a two-dimensional surface which is having the length and breadth with negligible thickness. A regular plane surface is one in which all the sides are equal. In which all the sides are equal. A plane surface is also called as a plane or lamina or a plate. So it can be, if you look at all the problems in the primer, you might have observed that sometimes they might call as a plane, sometimes they might call as a lamina, or sometimes may call as a plate. So it can be called in a different ways, okay? But it is a regular plane surface. So regular in the sense it is all the sides are equal. So when a plane surface is held, parallel to plane of projection, obviously it will be perpendicular to the other plane of projection. That we'll discuss with the example. Before that, we know what are the different regular plane surfaces. One is a triangle. I think all the three sides are equal. The regular, I think it's equilateral triangle. I'm going to talk about here. Equilateral triangle. Of course, you might have seen the isosceles triangles also. Some of the problems are there on the isosceles triangle also. Rectangle with 4 sides, and square, and then 4 sides once again. Pentagon, hexagon, circle. These are, I think you have started in the geometrical construction, how to construct the triangle, and you have learned about the how to construct the triangle, how to construct the rectangle, how to construct a square, how to construct a pentagon, hexagon, and circle, right? So next, before going to the projection of plane surfaces, you need to know how to construct all these regular planes. Okay. So next, when a plane surface is parallel, means, see, all the projection of planes are drawn in the first quadrant, keeping the object in the first quadrant. When the object is placed in the first quadrant, the front view is always obtained on the vertical plane. The top view will be obtained on the horizontal plane. So when a plane surface is parallel to one of the planes of the projection, the view of the plane surface projected onto it will be the true shape. It means what he's saying about is, if any object is kept parallel to one of the reference planes. Say for example, if it is kept parallel to the horizontal plane. If it is kept horizontal to the plane, that lamina, if you take the triangle itself, see here, if you take the triangle itself here, ABC is one triangle. I have kept this triangular lamina parallel to the horizontal plane. When I project this onto the, which is to which it is parallel, that is the HP. So the A is projected onto the horizontal plane like this, and B is projected to onto the horizontal plane, and C is projected onto the horizontal plane. So here, when viewing from the top surface, of the object, I'm going to get the true shape of the triangle, right? See, if you look at this, the shaded one is represent the true shape of the object. Is it clear what I'm talking? So when you look at from the top of this surface, okay, triangular, true shape of the triangle can be seen in the top view. When you look at from the front face of the object, this triangular lamina looks like a line view. So when the object is placed in the first quadrant, keeping that it is parallel to the horizontal plane, we are going to get the true shape in the top view. Similarly, if I keep the same triangular lamina parallel to the vertical plane, in the front view, I am going to get the true shape of the triangle. Got it what I'm saying? So in the top view, it will be the line view. So it is exactly opposite to the what I have drawn here. If I kept parallel to the vertical plane, if the triangular lamina is kept parallel to the vertical plane, if we kept parallel to this vertical plane, I am going to get the true shape in the front view. Whereas in the top view, I am going to get the line view. Exactly reverse of this. When the lamina is kept parallel to the horizontal plane, true shape is obtained on the front view. Okay, means on the horizontal, which is the view is drawn on the horizontal plane, that is nothing but top view. We know that in the first quadrant, when the object is placed, always the front view will be above xy line and the top view will be below xy line. So when the object is parallel to the HP, the top view will be the true shape. When the object is kept parallel to the vertical plane, the front view will be the true shape. That is the thing which you know. Okay. So here, when a plane surface is parallel to one of the planes of projection, the view of here the plane, one of the plane instance I have taken here horizontal plane. Okay, so that projected onto the horizontal plane will become the true shape according to this statement. When the plane surface is parallel to HP, the view of that plane surface which is projected onto it, that is the top view, will be true shape, because all the sides or edges of the plane surface will be parallel to the plane of projection. Similarly, when the plane surface is perpendicular to one of the planes of projection, see here, if this triangular lamina is perpendicular to the VP and it is parallel to the HP. So when the lamina is perpendicular to the VP, then we are going to get a line view. That's what the second statement says. When a plane surface is perpendicular to one of the planes of the projection, the view of the plane surface projected onto it will be the line view. So here the perpendicular to which plane? Vertical plane. So the projection onto the vertical plane will be the front view. So the front view will become the line view in this case, which I have taken the example here. This triangular lamina is perpendicular to this vertical plane. So the front view will become the line view. So coming to the third statement, say here there are three statements. One talk about the true shape. The other
Your voice is not audible, sir.
1 minute. Not audible. Hello. Lag is there. Might be technical issue. Okay. Maybe technical issue.
Anyhow, can you explain once more, sir?
Yeah, I'll explain. Anyhow, the recording will be given to the YouTube channel that I'll share to you. Okay. Okay, na?
Okay.
Right. Okay. Yeah. So here are the 3 points which you need to talk about. One is the true shape. The other one is the line view. The other one is the apparent shape. So we have talked about the true shape with the example, and line view with the other example. That is okay. So this is the true shape and this is the line view. One more we talked about, the third statement is apparent shape. So apparent shape, when we are going to obtain, when the plane surface is inclined to any one of the planes. See here I have taken the reference as horizontal plane. So my square lamina, I have taken the square lamina ABCD. I have taken the square lamina ABCD. So this ABCD is inclined to the horizontal plane. When it is inclined to the horizontal plane, with the top view which I am going to obtain will not be the true shape. Yes or no? Because it reduces the length of it. So the top view will not be the true shape. The shape which you obtain, if it is the square itself is parallel like this, then the top view will be obtained as true shape. But it is not parallel. It is inclined certain angle. It is inclined at certain angle. So the top view which you are going to obtain is a apparent shape. But this square is perpendicular to the VP. The square is perpendicular to the VP. That's why I am going to get the front view as line view. Front view as line view. The same can be applied by keeping the lamina perpendicular to VP as well. When I am going to keep the perpendicular to VP, the front view will be the apparent shape. Front view will be the apparent shape, and the top view will be the line view, and the top view will be the line view. Got it? Okay. Next, we'll go to the before going to this that 3 points. Once again, I'm going to repeat this. When a plane is parallel to any one of the planes, please for a clarification, you can check into the diagrams which I have shown. So here in the example, I have taken the triangular lamina. In the example, I have taken a triangular lamina. This triangular lamina I kept parallel to the horizontal plane. So what is the projection I'm going to drop onto the horizontal plane? It is the top view. Yes or no? When it is kept parallel to the horizontal plane, the projection onto the HP is top view. So the top view will become the true shape. That's what he's talking about here. In the second statement, when a plane surface is perpendicular to one of the planes of projection, the view of the plane surface is going to be, see here, this triangular lamina, if I take this is a perpendicular to this vertical plane. The lamina is perpendicular to vertical plane. So that is why it is the view which I am going to obtain is a line view. Okay. So third one is apparent shape. So apparent shape is nothing but when the lamina is inclined to certain angle. When the lamina is inclined to certain angle, see it is inclined. The line is inclined. When you take this horizontal line and then some inclination is there. So that is inclined to HP. So inclination to HP, the top view on the HP, which view I am going to get? On the HP, which view I am going to get? Top view. Why? Because it is in the first quadrant. Why? Because it is in the first quadrant. So in the first quadrant, the top view which I am going to obtain will be apparent shape because it is inclined. Because it is inclined. Will be the lamina, even though it is inclined to HP, but it is perpendicular to VP. It is perpendicular to VP. So that's why the front view looks like a line view. The front view looks like a line view. Got it? So next we'll go to the different cases which we have in the projection of planes. When the plane surface is inclined to both the planes. When the plane surface is inclined to both the planes. So here I have talked about, here it is inclined to only horizontal plane. It is inclined to horizontal plane. When this square lamina, it is inclined to both the planes. In the both views, if I obtain the front view, if I obtain the top view, both will give the apparent shape. Both will give the apparent shape. So if it is inclined to HP, I'm going to get apparent shape. Even if it is inclined to VP also, I'm going to get the apparent shape. If it is inclined to both, both views will be the apparent shapes. Both views will be the apparent shape. So in this case, the orthographic views cannot be drawn directly because both represents what? Apparent shapes. We don't get any true shape because the plane surfaces are inclined to both the planes. In such cases, the plane surfaces are placed initially so as to be parallel to one of the planes of projection. Very important point which I have made it as red. Okay, so placed initially so as to be parallel to one of the planes of projection. In the sense either HP or VP you have to keep parallel. It depending on the problem. Got it? So when the plane surface is inclined to both the planes, we cannot directly draw the views. That is why we are going to draw by keeping initially parallel to any one of the planes of projection. So that in the first set of views, one of the views will be projected in a true shape. When I kept parallel, we know that when a lamina is kept parallel to any one of the planes, the view onto it will be a true shape. Got it? So now then with the help of the first set of views, further set of views are drawn by tilting the plane surface in the inclined positions. We discuss, of course, when taking the problem. Okay, this method of working is known as change of position method. So we are following for the entire position of planes. We are using the change of position method. So two things which you need to remember here. One is when the lamina is inclined to both the planes. When the lamina is inclined to both the planes, directly I cannot draw the orthographic views, that is front view and top view. So for that reason, first we'll keep the lamina parallel to any one of the planes. Any one of the planes, in the sense here it is not like cannot be drawn parallel to HP or parallel to VP. It depending on the condition, we need to keep the parallel to one of the planes. Parallel to one of the plane. Okay. Then we are going to, based on the first set of views, there are totally 3 set views. 3 sets will be there. Among these 3 sets, using the first set of views, we are going to obtain the other set of views from the first set of views. That we'll discuss in the change of position method by taking one example, right? So here, projection of plane surface resting on an edge, resting on an edge or side on HP with its surface is inclined to both HP and VP. See here I have taken a one case. So projection of a plane surface resting on an edge or side on HP with its surface inclined to both HP and VP. So in this method, as I told you, as it is inclined to both HP and VP, as it is inclined to both HP and VP, directly I cannot draw. So first I need to keep parallel to any one of the planes. Here, how to decide which plane I have to keep parallel? How to decide which plane to which plane I have to keep parallel? Based on the resting on condition and the lamina inclination. As the lamina is inclined both HP and VP, I have to depend on resting on condition. As it is resting on what? Resting on edge. On which plane? On HP. So that is why I have to keep the lamina parallel to HP. Parallel to HP. So in this method, initially the plane surface is placed with the surface completely lying on HP with an edge perpendicular to VP, parallel to HP, and you place on the HP itself. Okay, means the distance between each side from the each side to the horizontal plane will become 0. So it is lying on HP, lying on HP completely with an edge perpendicular to VP, preferably to lie on the right side. Which one? Edge or side? The edge resting on edge, which I told about, that edge has to be lie on the right side. So that we'll discuss in the example. Okay, in this position, the front view will be the, when the lamina is kept parallel to HP, when the lamina is kept parallel to HP, the front view will be the line view. Top view will be the true shape. Top view will be the true shape. Got
Not
it?
able to hear.
Hello? Hello? Is it okay?
Sir, it's not audible.
Still?
Yes, sir.
Yeah. Anyhow, I'm recording this. You can check it out in the YouTube channel. Okay? Not a problem. Okay? In this position, the front view will be the line view coinciding with the XY line. See here, I'll take the example here. The initial position which I'm going to trace. This is called first set of views. This is called first set of views. In the first set of views, XY line, that is nothing but intersection of vertical plane and horizontal plane. When I place the lamina on HP, I have placed the lamina on HP by keeping like this. And BC, see here, the edges are nothing but AB is one edge, BC is one edge, CA is one edge. So AB, BC, CA, all these 3 edges we can call it as. One of the edges is resting on HP, I told. So that I have taken as BC, because the BC I kept perpendicular to the vertical plane and also on the right side, and also on the right side. When the observer is here and the observer is here, so right hand side, in the sense it is a BC is lying on the right side. See here, it is edge on the right side, edge on the right side. This edge, which edge? BC. Which edge? BC. So here, if I draw the projection of this lamina while viewing from the top, I'm going to get the true shape. So whichever way, in which view I'm going to get the true shape, that view should be drawn first. In which view I'm going to get the true shape, that view should be drawn first. Is it clear? So after drawing the true shape, because it is parallel to HP, top view I'm going to get the true shape. Because it is parallel to HP, top view I'm going to get the true shape. Once you draw the true shape of the lamina, then the front view is obtained from the top view. So see here I have drawn the projection. Once you draw the triangle of side, you say for example 30 mm, I'm going to draw a 30 mm triangle here, 30 here, 30 here, and 30 here, means with the 60 degrees here, with 60 degrees here. I think you know that how to construct equilateral triangle. So we have constructed the equilateral triangle on the top view. Once you draw the top view from point A, you need to project onto the XY line only. Why? Because the lamina is resting on HP. The lamina itself is resting on HP. Then the front view is obtained only on the XY line. So the A is projected onto the XY line. B and C is also projected onto the XY line. See here, B and C both are coinciding. Both are coinciding. Is it clear? Both are coinciding. Once you draw the A dash, B dash, C dash, then we are going to get in the front view as a line view. Top view is the true shape. This is called first set of views. When the lamina is inclined to both the planes, we are going to get the first set of views by keeping the lamina parallel to any one of the planes. As it is inclined to both the planes, resting on condition as based on HP, the lamina which I have told is here, it is resting on an edge or side on HP. Edge in the sense here, edge in the sense it is AB is called edge, BC is called edge, AC is called edge. A, B, C are called as vertices or corners. We can call it as corners. A, B, C are called as corners or vertices. AB is called as edge or side. BC is called as edge or side. CA is called edge or side. So as it is lying on HP, we need to keep the lamina parallel to HP and also on the HP and by keeping, as it is resting on edge has to come on right side of yours. That's why preferably right side. Okay, so keep the edge on the right side. So such a way you need to draw the triangle. So first you need to start with the BC. And then take the length of 30 mm from B, draw an arc to get the A, and from C is also drawn an arc and then cut both, and then you're going to get the A. So that equilateral triangle is going to be joined. Okay. So next, second view. So this is the first set of views. That's what we talked about here. So that the first set of views we are going to obtain. We are going to obtain by keeping the lamina parallel to any one of the planes. Here. Okay. So one of the planes instance I have taken the HP here. Why I have taken the HP? Because the plane surface is resting on edge on HP. The plane surface resting on edge on HP. That is why I have taken inclined to, that is I have taken as parallel to HP and on HP. See here, surface completely lying on HP with an edge perpendicular to VP. With an edge perpendicular to VP in the sense, don't confuse that edge is perpendicular to VP in the sense, this BC is drawn. See, the BC is drawn perpendicular to XY line. That means BC is drawn perpendicular to XY line. Means with above the XY line, what plane we have? Vertical plane we have. So that is why this BC is perpendicular to XY line. Got it? So next, if we talk about this first set of views which I have got obtained. So how we obtain? By keeping the surface or plane lamina lying on HP with an edge perpendicular to VP. In this position, the front view will be the line view and top view will be the true shape. Front view will be the line view. This is called front view, which is A dash, B dash comma C dash. So here, as I told you, B and C both lying on the same line. So when you viewing from this side, B and C will be coincide. So when you viewing from this object, B and C will be, C will be behind B, So both will be coincide, and it looks like a point view in the front view. Point view in the front view. Got it? What I'm saying here? The B dash comma C dash I am represented here means at the end of this line view, there are 2 points represents here, because here this line completely look like a one point. Is it clear? Right. So now step 2. Step 2 talks about next the plane surface. Next the plane surface, which is the line view. What is the line view here in the first set of views? In the first set of views, line view is nothing but A dash, B dash comma C dash. This is the line view. So this line view should be tilted about the edge. Which edge? The resting edge. Which is the resting edge? BC is the resting edge. BC is the resting edge. So this line view has to be tilted about this point. Tilted about this B dash C dash point. So this lamina is tilted in the second step. See, look at here. So this lamina A dash is moved up. A dash is moved up, but B dash C dash lying on still on XY line. It means that this lamina is tilted about this point. Tilted about this point. That's what is saying in the second step. Next, the plane surface is tilted about the edge, which is resting on HP, to lie on HP, because it is still resting on HP. No, so that is why the B dash should C dash and should lie on XY line only. That's why I kept there itself. Okay. Now to lie on HP, and the surface of the plane surface is inclined to given angle. Project the top view in the tilted position. Means once you tilted this line view, then this top view is obtained by drawing vertical projection lines. These are called vertical projection line of A, point A. So from A dash you will draw vertically downward, and then from A, in the previous top view, that is previous top view is this one, from A draw one horizontal projection. Both will intersect at this point. So that is represented as A in the second set of views. Got it? Similarly from B dash you need to project vertical projection from B dash like this. And where is the B in the previous front top view? Then from there you need to draw like this, horizontal. So vertical projection of B dash, horizontal projection of B, both intersect at this point. I'm going to get B. Similarly, C is going to be drawn horizontal projection like this, and C dash from here, vertical projection from this, both intersect at this point C. So you are going to get 3 intersection points of like A, B and C. Then join A to B, then B to C, then C to A. So this you are going to get in the second position top view. This obtained from this line view. That's what he has talked about. Project the top view in the tilted position. Now this ABC is different than this ABC. Why? Because this ABC is equilateral triangle, but this is not equilateral triangle because it is tilted about an angle theta. So we have talked about when the lamina is inclined. When the lamina is inclined, the shape which you are going to get is not true shape. This shape is called as apparent shape. Here it is a square, and there we have talked about the triangle. Got it? So this ABC is not equal to this ABC. Got it? Why? Because it is inclined to certain angle with HP. Is it clear? This is the second step. So first step, you need to keep the lamina parallel to any one of the planes. Here, any one of the planes means here the resting on HP. As the lamina is resting on HP, we need to keep the lamina parallel to HP. Got it? Similarly, in the second position, A, B, C. So directly you cannot get this ABC. The line view has to be tilted to a given angle. Then from the line view and the previous top view by drawing the vertical projection lines and by drawing the horizontal projection lines. We are going to obtain a apparent shape of the second set of view. Got it? So this is the very important first step is very important. When the first step is right, then automatically second step and third step will be right. So when if you go wrong by in the first step, then automatically step 2 will go wrong, step 3 is also go wrong. Where you can go wrong? Just by drawing where I am going to get the true shape. Generally people will be, see, when the lamina is inclined to HP, when the edge is resting on HP, so if you draw the front view is a true shape and top view as a line view, then you'll go wrong. So you need to know to which plane I have to keep parallel. For that, look at the resting condition as well as lamina inclination. Look at the resting condition and lamina inclination. If the resting condition on HP, keep the lamina parallel to HP. If the lamina is inclined to HP, keep the lamina parallel to HP. So if it is inclined to both, then resting conditions will be seen. So based on that, we need to keep the lamina parallel to any one of the planes. So here, as it is resting on edge, we are going to take the lamina is parallel to HP. It's parallel to HP. Got it? So first step and second step, any doubts? First step, second step, any doubts?
No, sir.
Even I am not able to audible. Hello?
No, sir.
Hello? Okay.
Hello.
Hello? Yeah. Can I end the session today for step 1 and step 2? Because step 3, it requires time to explain. Okay. While going to
Yes, sir.
step 3, step 1
Yes,
and
sir.
step 2 to be understand better. Okay. So step 1 and
Yes,
step
sir.
3 is very, very important. Rather than step 2, step 1 is very important. Step 1, if you have understand, then automatically step 2 and step 3 it is easily understood. Okay. So step 1
Yes,
is
sir.
Yes, sir.
only thing is you need to know how it can be kept parallel to one of the plane. To which plane I have to draw the parallel. To which plane I have to draw parallel. That is very important. Okay. So once again we'll meet at 12 o'clock. Okay. So I'm ending the meeting here. We'll meet at 12
Okay,
o'clock.
sir.
Yes, sir.